Hello, I am Dr. Ömür Tekince, and in this video I will show you how to perform spectral matching in EQMatch. In this example, we will match a set of earthquake acceleration records to a target spectrum. We will select the records, define the target spectrum, run the spectral matching analysis, and review the results using graphical outputs. By the end of this video, you will see how closely the match spectra approach the target spectrum, how to check the past status, how to review time history comparisons, and how to evaluate the generated outputs. Spectral matching is a method used to modify earthquake acceleration records so that their response spectra become compatible with a selected target spectrum. The approach used in EQMatch is based on a modern wavelet-based time domain matching algorithm. In this method, the record is modified directly in the time domain. The main objective is to bring the response spectrum very close to the target spectrum while preserving the original time domain character and energy distribution of acceleration record as much as possible. Instead of creating a completely artificial record, this approach applies controlled corrections only in the required period regions. With appropriate record and proper analysis setting, a very high level of agreement with the target spectrum can be achieved within the selected matching period range. In this example, we will see that the matched mean spectrum can approach approximately 99.9% agreement with the target spectrum. Now, let's move to the EQMatch interface. First, in the Project Setting tab, we check that analysis method is set to the spectral matching. One of the important parameters here is the matching or check period range. In this example, we will use a range from 0.1 seconds to 4 seconds. This range defines the period band where the agreement with the target spectrum will be evaluated. In a real engineering project, this range should be selected based on the structural periods, code requirements, and project-specific engineering objectives. Now, we move to the Files tab. Here, earthquake acceleration records can be loaded in AT2, ASC, TXT, or CSV format. In this example, we will use a previously prepared set of horizontal acceleration records. After the records are loaded, each record component can be seen in the record list. For spectral matching, we also need to define a target spectrum. EQMatch supports both user-defined target spectra and code-based target spectra. In this example, we will use the code-based target spectrum option available inside the software. After selecting the code and entering the required spectrum parameters, we will generate the target spectrum. Once the target spectrum is generated, the spectral matching analysis will be performed according to this spectrum. Therefore, it is important to check at this stage that the target spectrum has been defined correctly. Now, we move to the Record Selection tab. Here, we select the records that will be used in the spectral matching analysis. In the spectral matching workflow, EQMatch can treat horizontal components as independent records. This approach allows each horizontal component to be matched separately to the target spectrum. After completing the record selection, we quickly check the analysis type, the number of selected records, the target spectrum, and the matching period range. Now, we move to the Run Analysis tab. In this section, we can review the pre-analysis summary. The analysis type is spectral matching. The target spectrum is selected. And the number of records look correct. If everything is correct, we click the Run Analysis button. At this stage, EQMatch applies the Wavelet-Based time domain spectral matching process to each record. When the analysis is completed, the match records grabs spectrum data and result tables are generated automatically. In this example, we are performing spectral matching using only 3 acceleration records. However, users can load and match as many acceleration records as they need it. After the analysis is completed, we move to the Results tab. Here we can see that the spectral matching status is initially soft review. Some parts of spectrum are slightly below the target spectrum. To make sure that mean spectrum remains above the target spectrum, we click the Apply Final Uniform Scale Factor button. After applying this final scale factor, we confirm that the spectral matching status becomes pass. In the upper section, we can see the minimum ratio, mean ratio, maximum ratio, and final scale factor values. The minimum ratio shows the lowest ratio between the match spectrum and the target spectrum within the selected period range from 0.1 second to 4 seconds. The mean ratio represents the average agreement between the matched mean spectrum and the target spectrum. The maximum ratio shows the maximum amount by which the matched spectrum exceeds the target spectrum. If the target spectrum and the match component mean spectrum are almost overlapping in the pilot, we can say that the spectral matching process has been successfully. In this example, within the selected matching range, we obtain a very high level of agreement with the target spectrum approaching approximately 99.9%. Now we move to the Graphs tab. First, we open the matched horizontal component spectra and mean graph. In this graph, we can see all match record spectra, the mean spectrum, and the target spectrum together. This graph is very useful for evaluating the overall behavior of the record set. If the mean spectrum closely follows the target spectrum and the individual records remain within reasonable engineering limits, the analysis result appears more reliable from an engineering point of view. Now, let's look at a time history graph. Here, the blue line shows original and the orange line shows final match. The original acceleration, velocity and displacement, and final match acceleration, velocity and displacement time histories are shown comparatively. After spectral matching, it is not enough to check only the response spectrum agreement. It is also important to review the changes in the time domain. It also has Fourier amplitude spectrum, power spectral density, and areas intensity histories. These graphs help us evaluate how much of the original character of the record has been preserved. At the end of the analysis, EQMatch does not only generate graphs, it also creates matched records, spectrum data, time history data, and output files that can be used for reporting. We can see their matched records. It's also G units for acceleration and meters per second squared units for acceleration records. We can see final matched acceleration, and we can also see for the G unit, and we can show the pilots time histories, spectrum comparison, Fourier amplitude spectrum, power spectral density, areas intensity history, and we can click add the report all of these graphs. Add the record, open reporting. In the Graphs tab, a numerical data table related to selected graph can also be displayed. If needed, the user can export graphs and data files. From the Reporting tab, the analysis results can also be prepared Word, PDF, or TXT format. These features make it easier to include spectral matching results in project files, technical reports, or academic studies. We can see spectral matching report. Project name, analysis mode, selected horizontal component, matching period range, wavelet count, all of these, all graphs you can see, and the last note, short engineering note, you can read all reports. In this video, we demonstrated how to perform a spectral matching analysis using EQMatch. To summarize, we loaded earthquake acceleration records, generated a target spectrum, selected the records, ran the spectral match analysis, checked the past status and spectrum ratio values in the results tab, reviewed match spectra and time history comparisons in the graphs tab, and finally discussed output and reporting options. EQMatch's wavelet-based time domain spectral matching approach aims to provide high precision agreement with the target spectrum while preserving the original time domain character and energy distribution of the earthquake record as much as possible. To try EQMatch or review the available license options, please visit our website eqmatchsoftware.com. Thank you for watching.